All right, next one, x minus 3 squared. So we're going to go through that same process, square the first term, minus 2, and then we're going to take a times b. So that would equal 3x plus 3 squared. So x squared minus 6x plus 9. So again, you're going to end up with a perfect square at the end. Also, you could get to this spot by factoring. We're just trying to make it quicker. And you're welcome to go from here to here. You can do that. That's perfectly fine. Okay? All right, so we're going to jump to having a coefficient in front of our variable. Okay, so 3x minus 8 squared. So this time a has a coefficient, which is going to look a little different. So we still have to square a. So I'm going to put that in parentheses. I am going to show the steps on this one. So 3x squared. I'm going to have a minus 2. And then what would 3x times 8 be?
20.
You would get 24x and then plus 8 squared. Okay, so then I'm going to simplify this. So I have to remember to square the 3 and square the x. So I'm going to end up with a 9x squared minus 48x plus 64. So here I have two perfect squares, one at the beginning and one at the end. Okay. This one looks a little bit different because we don't have a number for our b term. We have a variable. So I'm gonna, and I have an addition sign, so it's a plus 2. So 3x squared plus 2, and then what would be a times b?
3xy. 3xy.
Just 3xy. And then plus y squared. Okay, so if I simplify that, my first term is going to be what?
9x squared.
9x squared plus 6xy plus y squared. Okay, so the next thing we're going to write is one more pattern, and I want you to call this, I think I had you label difference of squares last time. We'll go back and fix that. Difference of squares. I jumped ahead of myself. So this is difference of squares. So you're going to need to go back and not write that on the other one. We'll fix it here in a minute. So difference of squares is when you have a binomial times a binomial, and they're exactly the same, except one is a positive, one is a negative. And that is always going to equal a squared minus b squared. It's always going to cancel out the middle term. If you have a binomial times a binomial and they're exactly the same except their signs, it's going to cancel out the middle term. So in this case, it is a lot faster than foiling it and then realizing that middle term cancels out. Okay? So an example of this. So here we have the same exact binomial, just one's positive, one is negative. It's going to always turn into a squared minus b squared. So t squared minus, and then what would 5 squared? 25. And this should always be a perfect square. So these are usually quicker and a little easier than the ones we just did because it just turns into two terms. Okay, so x plus 10 times x minus 10. Again, same exact binomial. The only difference is the signs. It's going to turn into squaring the first term, so x squared. And then it's always going to be a minus. And then the